Hello YouTube, welcome to another video on the ALS Software Engineering Program. Today we want to look at a video, the 0x013.c more single linked list. So the first question is, what is a linked list? I already covered some basic explanation on the previous video, the 0x12.c single linked list, but let me just quickly do some basic explanation here. So a single linked list is a container, right, that has a value inside. So let me say this is a container that has a value 2 and it has a relationship with another container. Okay, so this container also has a value, let me say 10 for example, and this relationship goes on to other container. Okay, so now in single linked list, right, we have the head, which stands for the H, and the tail. So a single linked list is a container that has a head and the tail. The head is the starting point and the tail is the end point. So every container has a relationship with another container and they has what? A value. All right, so let us see some visual explanation and some method of a single linked list. So I am currently on the visualargo.net. So I'm going to create an empty linked list. Okay, sorry, let me just create a random linked list first. So this is a random linked list and you can see we have a container that has a number in it, and this container is called what? Node, right? So one node has a relationship to another node. Okay, so this has a relationship with this. You can see the arrow is already there. Okay, but it starts from what? The head. The starting point of every linked list, what is the head? Okay, which I used to label it as what? H, and it goes down to the tail. Okay, so this is what the tail. If you look at it, every node in a linked list has a relationship with other nodes, just as how I have explained. So let me say, for example, this node, right? This node, we want to perform an operation, and the operation we want to perform is to remove an item. So I want to remove from head. So if I want to remove from head, okay, so all I need is to click on the remove and you can see the head has been detached. The previous node that has the value 88 has been detached, and if you look at the right part of the screen, you can see, so it says if empty head, do nothing, right? It means if the linked list is empty, do nothing, or else take the head as temporary, then set the head to the current head.next, then delete the temp head. That is what just happened. All right, so let me delete, let me perform another operation. I want to remove from the tail. So let's see what happens. Note the animation. You can see it starts from the head and it started to move straight to the tail until it finds the tail. And when it finds the tail, it break out the tail and assign the previous node, the former previous node to the tail as the new tail. Obviously, if you follow up with my video, at the right hand side of the screen you can see it says if empty, do nothing. Then you can see the while loop here, right? It keeps on checking, and we already assigned a temp tail, right, as head.next. So what we're doing, while there is a next item, so we keep on assigning the temp tail as the next item of the current node. So that continue until we reach the point whereby the next item is null. That means we have gotten to the tail. So what we need to do is to delete that tail and set the current tail to the previous, which is this one. Okay, so there is another operation, right, we can do on a single linked list, which is insertion. So I want to insert after the tail. So I want to insert the value 80 after the tail. So wash. So you can see what happened. All we need to do is to locate the current tail, and when we locate the current tail, we create a node, then set the new item, which is the new node we just added to the linked list as what the tail. Okay, so what if I want to search? So let me search for a value now. So you can see it goes from the head, set a very temporary, and search from head to tail, and the value 7 could not be found in the node, so definitely will return not found or -1. So what if we decide to find a value that exists? Okay, so let me say I want to find 95 exists in my linked list. So I'm going to click on search. You can see it keep on searching from the head and get to 95. What we have to do is to return the index of that node. So I hope this gives you like a clear picture of how a linked list works. So the takeaway here is a linked list is a container called node, right? And every container has a relationship to the next item. And every linked list has what? A head and a tail. Okay, so with this understanding, right, let us go to some basic code example. So I have make up a linked list on our online compiler, right? So I used this in my previous video, which is the 0x12, but there are some missing method. So let us look at the method quickly. First of all, this is the structure of the node. You can look at append, and this add a new node to the end of the linked list. So this is going to add to from the tail. This is going to add a new node from the tail. Okay, so if we scroll down, right, print list, and this prints the content of the list. There is another method which is called free list. This free up the memory used by the linked list. And there is a new method which I added here. This search for a value in the linked list. And there is another method which is insert at head. So this one inserts at the head of a linked list. Okay, so here is the main method, and here is where we are going to perform some basic operation. So you can see this is a node, and in this node I am appending 1 2 3. So meaning append here, I am adding at what? The tail. Okay, so if I run, you can see I have what? 1 2 3. Okay, let me add one more value here. Let me append 22. Oh, sorry, 33. So I'm going to run. You can see the value 33 has been added to the linked list. Okay, so what if, right, I decided to insert at the head? I want to insert 22 at the head. Okay, you can see I call the function insert at the head, and I am calling the print method, which is going to print the current value of the linked list. So I'm going to run, and when I run, you can see the first result, the first print is coming from this part, line 89, and the second print is coming forward, line 92. So note that we are inserting at the head. We are inserting the value 22 at the head on line 91, and that is why we have 22 at the head of the linked list. Okay, all right, so the last method you can see here is what is free up the memory of the linked list. There is a search method, right? So let me uncomment this. So this is what the value to search, right? So does 2 exist in our linked list? Let us run that. So I'm going to run, and you can see we found the value 2 in our linked list. Okay, so what if we decide to search for the value 77 and we run again? We can see did not find the value 77 in our linked list. So this is just like a basic linked list. So I'm going to put a link to the Git gist where I will be putting this simple code so that you can access it and play around with it. I hope I was able to explain how linked list works and give you proper understanding of a linked list. So with this understanding, let us move to the project section. Hey guys, welcome to the task section, and I am very certain that you must have read the project requirements. Okay, so one of them we shall pick, which is what? Your header file should be called the list.h. So all our prototype, which is this prototype, should exist what? In the list.h. So like I always do, the first thing we need to do is to create our project directory. Okay, so I just copy mine, and you can see if I do pwd, which is my present working directory, you can see I am in the ALX low level programming, and exactly that is where they want us to what? Create our directory. Excuse me. So I'm going to make that directory, and I'm going to paste what I've copied. So that directory now exists. So I'm going to navigate to that directory. So this is going to be what? Our working directory. Okay, so the first thing I want to do is to create what? The readme.md. So I'm going to create my readme.md. So it should not be empty, right? So you can include everything you want to achieve here, but I will just put the name of the project. Okay, so the next thing you want to do is to create what? Your prototype file, which is list.h. All right, so let me show you my own. You can do yours by using vim list.h. Okay, but let me just show you mine. Okay, so x13. Okay, list.h. Okay, so you can see this is my own list.h. So all I need to do is to copy all the prototype and put it inside. So when you've done that, right, the next thing you want to do is to check if you have done the right thing. Okay, so test your file using Betty, and you can see there is no error. All right, so when you've done that, the next thing you want to do is to write your solution, tackle the task. So the task 0 says write a function that prints all elements in lists underscore t. Okay, list int underscore t. All right, so this is the prototype for this solution, and you can see we've already added that to our list.h header file. So our solution should be what in this file? 0 dash what? Print underscore list int. So you can write your solution like this. Excuse me. Okay, so let me show you my solution. If I decide to be writing everything, it's going to take a lot of time. So the file should be 0 underscore list. Sorry, let me look at the name again. Okay, sorry, 0 print underscore list int.c. So I now have the file in my current directory. So here is my solution. You can see. And the next thing we want to do is to change the permission of this file. Okay, so to change the permission of this file, I don't even think this is necessary, but let's just change the permission of this file because I did not do that. All right, so to change the permission of the file, all you need to do, you can change the permission of every file in the current directory using this command. And if you do ls-l now, you can see every file now has what the read, write, execute full permissions. Okay, so the next thing you want to do is to test out your file. So to test out your file, you need to copy the gcc command here and run that file. But before we do that, we need to create what's our test file, which is the 0-main. Okay, so I'm going to copy the 0-main file to this part. Ctrl C, then create that file 0-main.c. Okay, enter. I for insert, then save. Okay, we now have what the 0-main file. So next thing is to copy this command. So let me copy that. I'm going to copy the gcc command, then run this program. So if you run and there's no error, you should know everything is good. And the next thing you want to do is to test your output if you have what the same results. So you can see mine is 98 and 2 elements. So you can see 98 what and 2 elements. You can see basically I have what the same result. And next thing you want to do is to do your gate push. So this is just only one example. I think is okay for this tutorial. Okay, so I'm going to clear my screen. Let me just quickly show you the complete project, and there's going to be a link to my GitHub repository of the current project. Okay, so let me just show you the complete project. Now shall the 0x13. Okay, 0x. Okay, so at the end of the project, right, you should have your current work like this. Okay, so you have what your current work like this. So there's going to be a link to my GitHub repository whereby you can look at it. Ensure you're typing it yourself. If you are not typing yourself, you must have issue with Kimba and the plagiarism tracking machine. So guys, that is all for this video. Thank you very much for watching, and I'll see you in another video.